So the next speaker who's going to ask the really big questions is Ray Jayawardhana. Ray's been with us before, and I've asked him back because he asks the really big questions. And while we want to know what our place is in the universe, every day there is information that suggests that that place is getting smaller and smaller. Once upon a time, we thought the solar system revolved around the Earth. Then we learned that we revolved around the sun. Then we learned that there was a galaxy. Then we learned that there were 100 zillion billion galaxies. Once I was told that there were 100 million stars in our own galaxy. Now I'm told that there are a billion stars in our own galaxy and a billion suns in our own galaxy. Ray, where will it all end?
Good to be here again. Thanks. Surreal doesn't begin to describe this scene. Let me start again. Surreal doesn't begin to describe this scene. There we were on a parched plain in the Altai Mountains of Western Mongolia when we came across this shaman dressed in a colorful cloak, surrounded by about 100 people next to an impromptu rock shrine. 3 by 3, these people kneeled in front of the shaman for a blessing, which consisted of a mouthful of alcohol spit on their heads and a whiplash on their backs. There was a long way to travel to witness this unusual ritual. After traveling halfway around the globe to Ulaanbaatar, the capital of Mongolia, we had to take a domestic flight out west to a dusty outpost, but the worst was yet to come. There, we got into an old Russian-built van with very poor suspension for a 16-hour roller coaster ride through the mountains and the plains to get to this incredible place. The landscape along the way was spectacular. The ride was rather uncomfortable. And we ran into nomadic people who lived in yurts with their herds and a satellite dish often. Some of them on the move with all of their earthly belongings on a few camels across the plains. And once in a while, we stopped for a meal, which often turned into an impromptu sing-along session. The problem was a maniac of a driver who decided, despite being already pretty darn exhausted, to take a few swigs of vodka at every stop. Trust me, more than a few times we feared for our lives, especially when the van was snaking along a narrow ledge with a steep fall right next to it. Finally, when we caught him nodding off at the wheel, we persuaded him to stop and take a snooze. And the rest of us got to enjoy the spectacular skies of Mongolia. The reason we went to all this trouble, taking risks with our lives, was to see this spectacle in the sky, a rare phenomenon, a total eclipse of the sun, best seen, in this case, from this remote corner of our planet. And it did live up to our expectations. It was all that it was cracked up to be. One of my colleagues took this stunning image of the solar corona during the totality, which lasted a whole of 2 minutes, a 16-hour van ride for a 2-minute event. But the spectacle on the ground was no less mesmerizing. As the sun started to wither, I felt a chill. The winds picked up. And the shaman's assistant He got in my head. The shaman's assistant lit a bonfire. The shaman himself turned his back on the disappearing sun, started beating his drum. And the crowd around, the 100 Mongolians, started hooting and howling as loudly as they could. They were making all this noise to dissuade the monster Ra from swallowing the sun. Thankfully, their gambit worked. The sun slowly regained its full spherical shape and luminosity. What it does highlight the dual spectacle of the ritual on the ground and the eclipse in the sky. What that does highlight is the deep and enduring links between ourselves and the heavens above. As you know, for a good chunk of human history, people revered and feared what was happening in the skies above. In particular, comets, for example, were seen as omens of death and destruction. And yet, our predecessors also relied on the stars to tell them when it was time for agriculture. The stars helped them keep track of the seasons, for navigation in some cases, and often they aligned their temples along celestial events. Sitting here in Kerner Hall today, you might think that we're immune from all that the universe is out there, remote and untouchable, far, far from the daily concerns and occupations of our lives. That's far from the case. I'm here to try to convince you that the connections between ourselves and the universe at large are many and intimate. We might not worry about Ra gobbling up the sun, but we are still at the mercy of this star some 150 million kilometers away from the Earth. Because every once in a while, for example, it ejects vast clouds of charged particles. These solar flares, when they reach the Earth a few days later, generate spectacular northern and southern lights, the aurorae. As seen here from the International Space Station flying above Australia, in this case. Quite spectacular phenomena if you ever get a chance to see in the north of Canada. But that's not all these solar flares do. The biggest one in recorded history, in 1859, called the Carrington event, after a British astronomer who found the sunspots and the associated flare, disrupted the internet of the day, brought down the world telegraph system, put it out of commission for a while. The aurorae lasted for 3 full days, seen as far down as the tropics, far from the poles where they're usually seen, and might have reduced the ozone cover of the Earth by a few % for several years. Today, given our reliance on technology, if anything, we are a lot more vulnerable to solar flares than we were in 1859. The economic impact could be staggering to aviation, to communications, to the power grid. Could even lead to social unrest in some places because the power goes out for days or weeks or even months. So much so that even insurance companies like Lloyd's have begun to take notice. I'm afraid to tell you that's not the only threat we face from outer space. This is what the inner solar system looks like just now. If you notice the orbits of Mercury, Venus, the Earth, and Mars, Earth is hurling through a swarm of asteroids at 100,000 kilometers an hour right now, right this second. And somebody once tried to convince me at a bar that gravity is just a theory. As Hollywood has tried to remind us time and again, hitting one of those asteroids could be disastrous. And we had a stark reminder just last year when this fireball meteorite exploded over Russia with an energy equivalent to 500 kilotons of TNT. And of course, through Earth's history, there have been many, many impacts of space rocks on this ground, including the asteroid that probably triggered the extinction of dinosaurs 65 million years ago. One way to try to understand the threat these objects pose is to study pieces of them that fall on the ground. A few years ago, I had the opportunity to travel to Antarctica as part of a meteorite collecting expedition. I tend to like these distant, remote places on the globe. It was the US Air Force that flew us on a C-130 from Christchurch, New Zealand to McMurdo Base on the coast of Antarctica. And after about 10 days of training and preparation and packing, we were transported to a seasonal camp in the Transantarctic Mountains. And from there, 2 by 2, we got into a little Twin Otter aircraft on skis with Canadian bush pilots at the helm, by the way, for the last leg of our journey. They dropped us off literally in the middle of nowhere, halfway between the Antarctic coast and the South Pole, with our supplies. That's where we set up camp for the next 5.5 weeks. These were our cozy digs for 37 nights for 6 men and 2 women, disconnected from the rest of the world except for a satellite telephone. Except for a few whiteout days and days with incredibly strong winds when you couldn't tell the sky from the ground in whiteout conditions, we went out on the ice sheet, on skidoos and on foot, looking for rocks fallen from space. These are not meteorites that fell that week or that month or that year. These probably have been sitting on average for thousands or tens of thousands of years on the ground. The reason they survive a lot longer in Antarctica than elsewhere on Earth is because there's so much less weather down there. It's an incredibly dry place. And despite what Thomas Jefferson had to say when he heard that 2 Yale professors had picked up a rock in Connecticut that fell from the sky, we actually found tons and tons of meteorites, 900 of them in total. And here I'm going to hold in my hand a piece of our history. This is not from 100 years ago, or 1,000 years ago, or even 10,000 years ago. This is from 4.5 billion years ago, a bit of debris left over from the birth of our solar system and our own planet. This one isn't from Antarctica. This one is a piece of a meteorite that fell in Mexico in the late 60s. Imagine that. You're holding a rock that's 4.5 billion years old. What's more, there's growing evidence that there are building blocks of life itself, organic molecules, nuclear bases of DNA in these meteorites. So they may have had something to do with delivering organic material to the young Earth in the first place. Of course, our connection to the heavens go much deeper than that. The ultimate building blocks of life are the atoms that make up the cells in our bodies. And where do they come from? You must thank dead stars that you're here. That's because the iron in your blood, the calcium in your bones, the oxygen that you breathe, all were cooked up through nuclear fusion in the bowels of stars that lived and died long before our own sun came to be. These stars exploded spectacularly as supernovae, like this one seen in 1987 in a neighboring galaxy of the Milky Way, and scattered their debris through space, seeding our galaxy with the heavy elements needed for life. And those elements got incorporated into next generations of stars, including our own sun, and therefore its retinue of planets. So to say that we are children of the stars is not just a nice poetic sentiment. It is an astounding scientific fact. Our cosmic explorations don't just allow us to make sense of our origins, how we came to be, but they could also illuminate our present condition and perhaps allow us to get a better sense of our place in the scheme of things. This photograph, taken by Apollo 8 astronauts in 1968 on Christmas Eve, was the first time that we saw ourselves from so far away. The Earth hanging there in the pitch black sky in stark contrast to the barren landscape of the moon. Not only looked beautiful, but it also looked fragile. Many people credit this iconic image with inspiring the environmental movement. 4 years later, Apollo 17 astronauts took this image of the entire planet, came to be known as the blue marble, and since then, we've seen our planet from much farther away. Here's how the Earth and the Moon appear from Mars. A picture taken by the MRO spacecraft with the high-rise camera. From even farther away, the Voyager 1 spacecraft, in the outskirts of our solar system, over 6 billion kilometers from where we are, looked back and took this iconic picture of the pale blue dot, as Carl Sagan famously described it. That's us. What a perspective. On the one hand, it could make us feel small and insignificant, but on the other, don't all our earthly quibbles look rather petty from this kind of perspective? Today, just over the last 20 years, we astronomers have discovered thousands of planets circling other stars. Those stars that you see in the night sky are other suns. Some like ours, others quite different from ours. And we've learned that planets and planetary systems are ubiquitous, and they come in an incredible diversity of forms. And now we are on the verge of identifying alien worlds that, at least in principle, could harbor life. Imagine the ramifications if we were able to find definitive evidence of life on one of these planets, to confirm that we are not alone in the vastness of the cosmos. Imagine how that would affect the way we see ourselves, the way our religions, our arts, our sciences would go on. I hope I've convinced you that our exploration of the universe isn't only about finding out where we came from, but it's also about making sense of who we are in the most profound and fundamental sense. Not to mention the sense of wonder that it nurtures in all of us. Thank you.
You want to own this book? You want to get as puzzled as I am every time I try and turn my mind to astronomy, cosmology. I want to ask only one question. If it's infinite, how come we can measure it?
It's not infinite.
It's not infinite.
Not the universe that we live in. We can measure it because we can measure the photons, the light that reach us from these planets, from these galaxies, and spread them into their constituent colors, the spectra. And they tell us what these objects are made of. We could actually know that the same elements that constitute us and our planet are the ones that constitute stars hundreds of thousands light years away. We're very tightly, intimately connected with the rest of the
And out
universe.
there, 13.7 billion light years at the edge.
Everything I talked about today is a lot closer. This is just the local neighborhood, just
Right.
a few hundred light years.
Right.
Right? I didn't even go that far.
Right.
Not today.
Right. But is there a sense in your business, in your industry, that there are universes beyond ours?
There well could be. That would be much harder to measure. But the one that we're living in is spectacular enough and mysterious enough and full of wonder to keep us busy for now.
At least another couple of weeks. Anyways,
All right. Thank you.
Thank you so much, Ray. Yeah. Thanks.
We'll walk this way.